one of the important topic in physics is kinematics. Kinematics is the language of motion of the particle, which means that we will provide a description of any particle that is in motion or maybe in at rest. One way to describe the motion is by its position vector and a displacement. We can also provide a description using the velocity and also the acceleration. Description also the particle can be described by means of the graph. But in this video, let us focus on the position vector and displacement of the particle. Now, position vector and displacement are very important because if we have the position vector and displacement, we can provide the velocity. And by the use of the velocity and position vector, then we can provide the acceleration of the particle. So, let us understand now what is position vector and displacement. Now, consider a particle that is moving. Let us say a car moving in space. And if we want to describe the motion of this particle, then all we need to do is to provide a reference point, because we cannot describe the motion of the particle without a reference point. So if we consider three-dimensional axes, then this is actually describing in space, which means that the position of the particle can be described from the origin of the Cartesian towards the point of the particle, and we have three coordinates of that. So the distance from the reference towards the point is called the position vector. Let us say vector R1. So then it follows that there are three components of this position vector. We have the x component, x1, we have the y component, y1, and we have the z component, z1. These are all vector. So if we take the vector sum of these three components, the answer should be the position vector of the particle at point 1, or vector R1. So mathematically written in that manner. Okay, so meaning if we have the value of the magnitude of x1, y1, and z1, then we can provide the magnitude or the value for the position of the point at R1. So we have, suppose we have 5 for x, 4 for y, and 2 for z, and are all positive, then we can write the position as 5 I hat plus 4 j hat plus 2 k hat. So remember that I, j, and k are the unit vectors assigned to the corresponding axes. Now, if this particle moved to another point, so therefore we have now another position. So for every point of the particle have a corresponding position. So we have different position, and we can call this as R2. And the R2 has again three coordinates. We have the coordinate along x, coordinate along y, and we have the coordinate along z, and they have different value in previous. Okay, so then we can write R2 as x2 plus y2 plus z2 as its vector sum, because the vector sum of the components is actually the vector of that at that point. So if we have the values 7, 5, and 3 for the components of that vector, then multiplying its corresponding unit vector will result as 7i hat plus 5j hat plus 3k hat. This is the R2 position, or the another position of the particle. So at any point the particle travels, we can always describe the position of the particle, and that is coming from a reference point, which means that we cannot provide the position vector without a reference point. Everything should be lying on its reference point in order to describe. So the R1, we can call that as initial position, and the R2 as the final position. So we have now the initial and final position of the particle. Now if we take the change in position of that particle from initial towards the final, so mathematically it's written as delta R. So the delta R is called as the position, the change in position, which means that there must be 2 points in order to provide a change in position. Now this change in position is actually final position minus initial, because the word change means it should be final minus initial. It cannot be interchange. Now the change in position, we call this as displacement, which means that the displacement can be computed if we have the initial and we have the final. So subtracting the initial, final minus initial, is called as the displacement of the particle. Okay, so the position is measured from the origin, but the displacement is actually the change in position of the particle. There is no change if we have only one position. Okay, so in our previous example, suppose we have R1 as 5g hat plus 4g hat plus 4k hat, and R2 we have 7 hat plus 5g hat plus 3k hat. If we wish to calculate the change in position or the displacement of this particle, simply subtract the final minus initial algebraically. We call this as the vector algebra. No? So subtracting the final position by the initial position, so we have to apply the vectors algebra on this. Combine the like terms. Take note that the like terms are the terms that have the same unit vector, which means that you have to remove the grouping symbol, then combine the like terms, and this will yield to a value of 2i hat plus j hat plus k hat. This is the displacement of the particle traveling initial towards the final. Okay, so that's it. Thank you for listening. So then